Thank you.
Okay, moving on to the next presentation. This is coming from SEMCO, probably the pioneer of TOPCon production equipment business. So SEMCO got really several proprietary technologies, and they were also first in several aspects like low pressure diffusion and also LPCVD, one of the early adapters of LPCVD for TOPCon production. The presentation is given by Raymond De Munnik, CEO of SEMCO Smartech, who is also a good friend of me. Welcome, Raymond. So,
thank you, Shravan, for your kind introduction. I'm really enjoying your conference as usual. So thanks again, Taiyang team, for organizing and having us. Allow me to share my screen. And my screen should now be visible to you. Can you confirm?
Yes.
Yeah. Excellent. So today, after basically giving a short introduction to our company, SEMCO Smartech, we'll be highlighting the global cell demand trend. We'll not spend too much time on equipment details, since I think our equipment is quite well known. We want to specifically look in some of the manufacturing aspects and considerations. And then as an eye-opener, we would like to show some basic cost comparison between different methods, LPCVD, PCVD, doped silicon, specifically for the rear side, also in connection with the previous presentation. And then we would like to show a little bit future equipment compliancy, comparing, looking at TOPCon, but also other P-type based technologies, TOPCon, and of course eventually also IBC, after which we will finish with the summary. SEMCO Smartech, basically SEMCO existing since 1986. We are in mass production PV equipment since the early 19teens. I think we're well known, part of ECM group and based in south of France. So we have around 7 years industrial cell technology integration track record with multiple large tier 1 players, originally starting in Korea, Taiwan, and then we've been educating also multiple Chinese customers basically to launch TOPCon. And I think we can say that we are at the base of the big TOPCon boom that is ongoing in China, and now also basically going into the rest of the world as we speak. But to give you an idea, in 2016, we already did TOPCon modules, multiple lines with LG in Korea, and also later in 2017, some back contact module lines. So we are quite well experienced in that field. Yeah. So we are basically a complete solar cell line process integrator, focusing on TOPCon and technologies beyond. So it means that we are taking a customer fully by hand by designing installation, startup and complete lines, of course, transferring or know-how, and have a team on site for the line optimization. So in 2016, to give you an idea, back then, TOPCon was around 23%. But as you've seen also in the multiple presentations before, typical customer efficiencies at this moment are basically exceeding 24.5%, some customers even 25. So we are providing line performance guarantee for the whole line. And we are integrating, of course, our own thermal equipment for diffusion, oxidation, LPC and PCVD, which is basically the heart of our core know-how. But due to the industrial sell-up and all the projects that we did, let's say in the last seven years, we gained all the experience for the full line integration. And I think nowadays we are the only, let's say, non-mainland based non-mainland China company that is able to have to offer the full TOPCon technology transfer. So let's have a look at market share, market demand in function of time. This is a nice graph presented by our colleagues from PV Infolink, showing timeline 2020, 2026 horizontally, and vertically the market share. And the central color here, of course, is that representing the current mainstream of PERC. What's also nice and remarkable is seeing the quite constant growth for heterojunction here in the yellowish color. But of course, quite very appealing is in green the big green demand for TOPCon. This is also kind of represented from the big 80 gigawatt plus installation which is ongoing for TOPCon as we speak. And as you probably know, I mean, the majority of these expansions is based on the traditional LPCVD technology, as it was originating basically from Europe, and specifically, of course, from our company SEMCO Smartech. So we see quite very bright future for TOPCon, and even customers basically considering PERC or TOPCon are now switching to TOPCon or starting with TOPCon straight away. So that's a very unique trend, which we of course welcoming. We'll show you also later why this is happening. So when we're looking at cost conversion trends, and basically looking again at the different cell technologies, we have the PERC cell again, comparing with TOPCon in green and heterojunction in a brownish color. We have the cost per watt in RMPs on the vertical graph, horizontal again time. And this graph is quite nice because it's showing starting 2080 all the way going 2026, and you've seen that basically PERC of course has made a nice cost drop, but has been stabilized over time. The vertical line is representing status today, the fourth quarter this year, where both heterojunction and TOPCon show again significant drop, but quite remarkable is that we see that the gap between TOPCon and PERC is very close, and heterojunction, despite multiple efforts, still showing this gap, mainly for metallization and contact cost reasons. So it's when we look at the whole industry and the whole scale of what we're all basically putting together with all the different companies, customers, and competitors, it's really remarkable what is currently achieved in the industry. So this is a really nice graph showing basically the efforts of all the equipment makers, but also the module manufacturers. Another nice slide, which is quite simplified, but it's showing module cost comparison, and I think it's an eye opener for multiple people that might consider entering cell and module manufacturing, comparing, hey, do I want to start with PERC or TOPCon or beyond? So we've just shown that PERC and TOPCon cell manufacturing costs are quite similar, but when we basically project that now at the full module manufacturing cost, comparing PERC with the TOPCon, again cost normalized, looking at wafer cell conversion and then also the module cost, assuming around 6% cost difference between P-type and N-type wafers. You can see at the module level that the manufacturing cost for the big companies on gigawatt scale is kind of very similar, very similar to PERC. And this is, from what we see commercially, one of the main drivers why now basically all our customers are either starting with TOPCon or switching with TOPCon, because of course the TOPCon modules have better properties, higher cost, watt density, etc., already illustrated by our customers previously. But I think more important from a business point of view, of course, higher revenue can be created. So this is big stimulus for the TOPCon boom, which is currently ongoing. Yeah? So we're all familiar with the typical TOPCon structure: ball emitter at the front and the tungsten oxide and the poly at the rear. So we'll not spend too much time on that. But in line with the presentation just before of Dr. Song, very nice. I would like to highlight some of the considerations concerning the cell manufacturing aspects. Of course, we look at the ingredients, polymeter, passivation, metallization, etc., linked to the, of course, good wafer quality. And this is fortunately a lot of effort is also done there. It's increasing a lot over time. But then you get basically into all the scientific considerations concerning a lot of different, basically endless technical properties, and is again balanced with the whole business aspects, and where of course cost is at the end still the major driver for a lot of decisions in PV, unfortunately. So today I would highlight, since we are equipment maker, also basically three major ingredients, and that one is the set of creating the emitter and preservation. Second one, looking into the poly and the tungsten oxide combination, and of course the PECVD part doing the preservation at the end. So when we look at the first set of equipment, we are start on the right with our Solus. This is the basically traditional boron diffusion equipment. As you know, our company SEMCO is the inventor of the LP diffusion. We were also the first one more than 10 years ago to step away from the traditional boron bromide precursor and switch that to boron trichloride. So this is all kind of becoming standard in market, also adapted by multiple competitors, together also with a horizontal wafer orientation. So we've seen trend-wise the preservation of the boron emitter switching from originally BSG, some PECVD, now into ALD. And yeah, we can conclude that ALD nowadays is really a must to have integrated into TOPCon flow chart, and specifically for the emitter basically preservation. Trend-wise for diffusion, we see the sheet resistance going up, exceeding 160 ohm square. J-Not's direction 10 femtoamp. So also here lots of development is done. And of course, as you have recognized in some cell efficiencies in the previous presentations, you see selective emitter basically now maturing. Multiple customers are running pilot lines and experimenting. You see also now the results of basically TOPCon cells exceeding 25%. And I can tell you that all these results are selective emitter powered or enabled. So next year we will see definitely this equipment, that this process is also maturing and becoming more popular. So looking at the rear side of the substrate, we have been basically since 2014 already working on which method is best. We have tried many different things: LPCVD, PECVD, ALD, lots of different combinations. But what we see industry-wise from our basically customers, and also from the biggest expansions that are ongoing on the gigawatt level, that the majority is still LPCVD based. And this is caused because we have managed to develop a reactor which is stainless and therefore doesn't break, despite propaganda from many other people. We have the wafers again horizontal in the reactor, so no issues with basically too much parasitic deposition, and therefore we have very nice control process, because we grow the tungsten oxide on the wafer and dope and basically deposit the polysilicon right on top in the same sequence without breaking the vacuum. And as we all know, this is very commonly accepted and working quite well, because we are doing this back to back. And this is also, I think, where another let's say other people trying and suffering from having this done in typical semiconductor style reactors. So we completely adapted our design for PV, loading 1800 wafers per batch, and that's working quite well. And for the doping, this can be done both in situ and ex situ, but typically we see most of our customers still choosing the ex situ path, because this is still has simply the best cost, the cost effect. Of course, trend-wise, LPCVD layers are thinning. I mean, initially 180, 160 nanometers, and now going direction 100 and below, since also the metallization solutions are really increasing. Yeah? And then the last basically equipment set I would like to highlight is our PECVD. I think we are well known for our vertical platform. We continue to have the largest wafer load inside the reactor. So here's more than 700 wafers per batch. G12. Of course, this system is capable to do the standard silicon nitride coatings. But for your reference, I mean, we just previously heard some talks about challenging in boats. I mean, we have these machines in mass production for IBC cells with metallic reactors doing doped amorphous silicon for already more than 5 years. So all these basically things are challenges are already covered and can be done. Of course, there's a lot of questions concerning PECVD versus LPCVD. So both methods are working, as also shown by previous presentation. We will show later in a bit what is the main driver for such decisions, which of course yield and cost. So these three main thermal choices are kind of resulting in following basic process flow. You have the boron first and after the clean, creating the rear side tunneling oxide plus the poly all-in-one step. It can be in situ doped or ex situ doped, as mentioned. And at the end, as we explained, the emitter is basically specified with the aluminum oxide. So clearly, right now, I mean, despite many trends, I mean, the majority of all gigawatt expansions, I mean, we're talking really, it's going 80, exceeding going 100 giga, is what we see is the clear inquiry for the early adapters that are expanding all LPCVD based, and simply because it's combining the tunneling oxide and the poly is robust, reliable. Yields are quite well, and also very important. Going to let's say future cell technology, the same equipment will be required. We come back to that later. It's another interesting slide from my colleagues. It's a little bit complex. It's showing three groups: vertically normalized conversion cost, and specifically looking at the forming of the tunneling oxide, the poly doped on top, the poly on top of that, then dope it and then activate it. So basically all these 4 steps. So instead of just comparing these steps individually, we really have looked at the combined steps, looking at intrinsic poly and phosphor doping, in situ doping by LPCVD and anneal, and last but not least, doing it by PECVD. And we are comparing every time at the left, basically SEMCO equipment with a third party. And nicely to see is when we focus on SEMCO equipment, if you compare basically cost for LPCVD when it's done right on a SEMCO machine at 42%, basically you can see that the PECVD costs are almost double. And big drivers in that factor, of course, is specifically the process materials. I mean, we have quite a lot of wafers inside the reactor compared to others, which is kind of causing also the deltas between the competition. Of course, process materials can vary from country to country, but ballpark you can basically see comparing intrinsic poly with the doped the amorphous silicon doped solution and activation, calculate all that together, you can see it's almost double. Of course, there can be some variations in these numbers, but I think the trend kind of speaks for itself. And this again underlines where why LPCVD mass production gigawatt scale at this moment. The LPCVD remains very popular, because it's simply super cost effective. So we are again preaching TOPCon in since the 2015-16. At that time, I already stated publicly, hey, this is wonderful, nice, and PNN type compliant. This is also basically confirmed now from our colleagues from Fraunhofer, which presented in Milan some wonderful results where they basically took the TOPCon process, changing the wafers and the wafer material from N into P, and have shown that with the same process, without basically doing a lot of adjustments, you can have very similar cell efficiencies as shown in this table, around 26.8%. which is quite remarkable. Of course, it's still done on the smaller wafer size, but it shows what kind of technical potential is inside these cell structures, independent from the material before optimization. So to reach such high efficiencies on P-type wafers, highly doped, high quality gallium doped wafers are required. So, and this of course is a trend which is already ongoing in market. We also can see that if let's say the contact, especially if the paste manufacturers can follow up, and if this trend can scale up and develop the paste further. Also, the P-type TOPCon cells named by Fraunhofer TopCore can really have a good chance to materialize in industry. And what's nice is that basically for the manufacturing, it uses the same equipment sets as we have just presented. When we look a little bit into a roadmap and fluctuations or choices in technology path and in function of cost down, you see the traditional TOPCon cell here at the top, which can basically which is already going into an N-type front-side selective P-type emitter. So this trend is ongoing, and as mentioned, next year we for sure see that maturing. And the potential next step could be when to drive the cost further down, so to find ways to shorten the boron drive-in. So this is where the laser, of course, is a very
Sorry
very
to interrupt, Raymond. You have 1 minute to finish.
Okay, please. Excellent. I will wrap it up. Yeah, and of course, I mean at the end with there's potential option also to bring the emitter to the back. So this is also all developments where the whole industry will be working on, which will kindly be supporting. So same for P-type, still further out due to wafer quality and also due to contract material development. But from our point of view, we are completely compliant, and even all the way up to the IBC cell, as we have shown and basically illustrated already in the past for mass production. So this brings me basically to the conclusion of my talk. I mean, TOPCon is mature. I think this is the very strong statement in 2022. There's a huge installation boom ongoing, and we see the first cell line installations for TOPCon now also outside China. Majority remains LPCVD based. Average efficiencies for experienced cell manufacturers is now exceeding 24.5%. We see some customers exceeding even 25 selective emitter based. And from a cost level point of view, we've displayed today that the module costs are very similar to PERC, where of course the TOPCon technology has much more potential for further cost down increase and cell efficiency, cost decrease and cell efficiency increase, as already shown by Dr. Song in his previous presentation. So, and last but not least, I mean, with all the different steps that we have shown, we would like to underline that the equipment choices that we are currently launching or let's say delivering for TOPCon are all set for these technologies. So with that respect, these factories are future compliant. And since we are doing these complete lines, I mean, we're happy to help newcomers to design, install, start up, and ramp up these complete TOPCon solar cell lines. So this is the end of my presentation. And again, I would like to give many thanks to the TaiyangNews team for organizing.
Thank you, Raymond. Indeed, it's a very good insight into the equipment world. Unfortunately, we don't have time, so please stay back. Anyway, you have to stay back for the panel discussion. So please answer. There are a few questions in the chat window. It would be nice if you can answer.
Okay. Thank you, Sharon.
Thank you.